Good morning, my dear student. Prep 3, Mr. Osama with you, Science of Teacher. Let's continue our curriculum. We have finished before unit number 1, speaking about chemical reactions and the type of chemical reactions and the rate regarding the speed of chemical reaction. Unit number 2 has 3 lessons. Lesson number 1 that we have finished before, speaking about properties of the electric current. Lesson number 2, speaking about electric current and cells. And we will study the difference between the two sources of electric current. Number 1, we have 2 methods to generate an electric current. Method number 1, changing chemical energy into electric energy in electrochemical cells like batteries. Method number 2, changing chemical energy or mechanical energy into electric energy, like a dynamo and a station generating an electricity. So the method number 1 regarding the batteries and the small devices generate an electricity, producing an electric energy from the chemical energy inside the battery. The second one, which is a dynamo or electric generator, produces an electric energy from the mechanical energy or kinetic energy. The electrochemical cells like batteries, as we see here, energy used chemical transformed into electric energy. The type of current is a direct current. Generator or a dynamo use mechanical energy to produce an electric energy, and the type of current is alternating current. What is the difference between direct current and alternating current? We will study it now. These figures represent types of dynamos, like a small dynamo here in the bike, and this is maybe larger dynamo used in some machines. We have already 2 types of electric current that we mentioned before. The type number 1, direct current or DC. Type number 2, alternating current or AC. What is the direct current? Direct current represents the current intensity which its intensity is constant intensity. We have mentioned before the battery here produces a direct current. So the battery or electrochemical cell produces the current which has constant intensity. But alternating current or AC producing variable intensities. So the electricity passing through a conductor in an alternating current has a variable intensity. To show the difference between a constant intensity and variable intensity, let's show this graph. This is a current. The red line representing a direct current which has constant intensity, rather than the green line or blue line represent an alternating current which has the intensity with a variable values. Here in the first step, the intensity will be larger than in the second one. Regarding the direction of the direct current, the flow of the electric current in the conductor in one direction. In the direct current, the flows in the conductor in one direction, from a positive pole to a negative pole in the battery, as we knew before. But in the alternating current, the flows in opposite direction. First, first the current moves in one direction, and after a while, after some time, after few milliseconds, the direction of the current will be in the opposite direction. The source of both direct current and alternating current, the direct current, its main source, as we mentioned before, the electrochemical cells, such as the simple cell and the dry cell. Alternating current, the major example is electric generator or dynamo, as we mentioned before. The distance that the direct current travels, it can transfer over short distance only. As we know that the small batteries applied in the remote control or small devices, not to be applied in the large devices like a refrigerator or air conditioners or TV. So the batteries which produces direct current, the current here transferred in short distance only. Otherwise, in the alternating current, the transference of the electricity in short and long distance, which is used in the house and street lighting. The use of direct current here, operating some electric machines such as torches and electroplating. Electroplating like this figure, the silver plate here connected to the battery, and the other pool connected to the metallic spoon or frog. The silver metal ionized from the silver plate and precipitated in the spoon, making electroplating or painting of the spoon with a silver color. Uses of alternating current in lighting house, streets, operating large machines and appliances in-house. We can convert a direct current or not. A direct current cannot be converted into alternating current, but the alternating current can be converted into direct current. This is the main comparison between the direct current and the alternating current, and this comparison is very, very important. Let's take another point, very important point, types of connecting cells in an electric circuit. We have two methods for connection of the electric cells. Method number one, connection of the electric cells or batteries in a series connection, like this. A positive pool connected to the negative pool, and the positive pool in this cell connected to the negative pool in the second cell, and so on. We can represent this figure by drawing the cells like this: negative, positive, negative, positive, negative, positive, negative, positive. This connection is called a series connection. Each cell here contains 1.5 volt. The EMF of each battery, 1.5 volt. In a series connection, to calculate the cell total EMF, we have to add these values of potential difference or EMF. 1.5 plus 1.5 plus 1.5 plus 1.5 producing 6 volt of total EMF of the cell. So in a series connection, we have to add or make a summation for the EMF of each battery, producing a larger EMF. This is the first type of connection, which is called a series connection. A second type of connection is called a parallel connection, like here. Here is a parallel connection. A positive pole connected to the positive pole, not like a series connection. A series connection, as we mentioned before, the positive connected to the negative. But here, positive connected to the positive and the negative connected to the negative pole. parallel connection, to calculate the total EMF, we take a one value only for each battery. If this battery contains a 2 volt or 1.5 volt and the other battery contains 1.5 volt, to calculate the total EMF, the total EMF of this cell is also 1.5 volt, not a summation. This comparison between connecting in series and connecting in parallel. Here, to calculate the EMF, we have to make a summation of EMF of each battery, but here we take only one EMF for only one battery, and this is the total EMF. Thank you very much for listening, and I'm waiting for you for any questions and any ambiguity. Thank you so much.